Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about capacitance from Cambridge A2 Physics. In this lesson, we will only focus on capacitance past paper questions. Here is our first question, and for this question it is given to us there are three capacitors and each capacitor has capacitance equal to 48 microfarads. It means they are identical capacitors. What we need to find? We need to find the total capacitance between points A and B. Here is point A and here is point B. Now the question is how we can answer this. In order to answer this one, we just need to understand two main concepts. So let me explain to you those concepts and then we will answer this question. So let's say we have these three capacitors there. As you can see here, they are connected in series. Let's say this capacitor is C1 and its capacitance is equal to C2 and the capacitance of third capacitor is C3. So how we can find the total capacitance? So the total capacitance simply is equal to 1 over C total, and this will be equal to 1 over C1 plus 1 over C2 plus 1 over C3. So this is how we can find if we have only two capacitors. Let's say we have set up like this, only two capacitors. If they are connected in series, let's say we have capacitor C1 and here is a capacitor C2. If we need to find the total capacitance, simply we can multiply these two, means the capacitance we can multiply and we can divide by sum of the capacitance, means C1 plus C2, and this is only valid for two capacitors connected in series, and this is similar to resistors in parallel. So if you remember from AS physics, it is similar to resistors in parallel. So when capacitors are in series, is similar to resistors in parallel. So this is one point we need to understand. The second one, we need to understand when the capacitors are connected in parallel. So as you can see here, we have this setup and these capacitors, you can see they are connected in parallel. So let's say the capacitance of first capacitor is C1 and capacitance of second capacitor is C2. So how we can find the total capacitance? So simply you need to add them, C1 plus C2 and C1 plus C2. So this is the total capacitance of this setup. If we have more capacitors connected in series in parallel, so simply you will go on adding here. That's all. This is very simple one, and this is similar to resistors in series. So this is similar to resistors in series. Now we understand how to deal with capacitors when they are connected in series and when they are connected in parallel. So the first thing we need to do is we need to identify which capacitors are connected in parallel and which capacitors are connected in series. So as you can see here, these two capacitors are connected in parallel and this capacitor is connected in series. We just need to find the total capacitance. So we can simply first of all find the total capacitance of capacitors in parallel. So the total capacitance for these two capacitors will be equal to, we can say the C total for these two will be equal to 48 microfarad plus 48, we will get this is equal to 96 microfarads. So now we can redraw this one. You can see here now we have two capacitors. One capacitor has capacitance equal to 96 microfarad and the other capacitor has capacitance equal to 48 microfarad. and these capacitors now they are connected in series, and we can find the total capacitance. Now if the total capacitance we need to find, that is CT, so simply we will multiply 96 with 48 and we will divide by the sum, means 96 plus 48. So our final answer will be equal to 32. So this is our final answer. This is how we can answer this type of questions. For part B, it is given to us the maximum say potential difference we can apply across any one capacitor, that is equal to 6 volts, and we need to find the maximum say potential difference we can apply between points A and B, means between this point and this point. As it is given to us the maximum potential difference we can apply across any one capacitor, that is equal to 6 volts. So let's say for this capacitor, potential difference we can apply across this one, that can be equal to 6 volts. So this one is okay, and this is the maximum potential. But the problem is that how about across these two capacitors, how much potential difference we can apply? For this one, simply we need to understand that Q is equal to CV. Q is equal to CV. This is one thing we need to understand. The charge on a capacitor is equal to its capacitance multiplied by the potential difference across the capacitor. Now voltage across this one is 6 volt, we can find the charge on this one. So the charge on this one will be equal to 48 microfarads, and if we multiply that one with the potential difference across this, that is equal to 6 volts, and we will get the total charge on this capacitor in this setup can be equal to 288 microcoulombs. Now how about charge on these two capacitors? So we need to understand is that as this capacitor and this, they are connected in series with this one, so the charge on this one capacitor is equal to charge on these two capacitors. So the charge on this capacitor simply will be equal to Q by 2, and the charge on this capacitor also will be equal to Q by 2. Now it means the charge on this one will be equal to 144 microcoulombs if we divide by 2, and the charge on this one also will be equal to 144 microcoulombs. As the charge on this capacitor is equal to Q by 2, and the charge on this capacitor is Q by 2, and the charge on this one is Q, and the voltage across this one, as we have already discussed, is equal to 6 volts. Now we can also understand Q is equal to CV, as the C is the same, all these capacitors they are identical capacitors. If this Q become half, it means the voltage also become half. It means the voltage the potential difference across this capacitor will be equal to 3 volts, and the potential difference across this one also will be equal to 3 volts. Now what we need to do next we need to find the potential difference between point A and point B. So in order to understand that one, simply we can assume there is a battery that is attached between terminals A and B. So the EMF of this battery has to be equal to 3 volts plus 6 volts, means 9 volts. So that is our final answer. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about capacitors and capacitance from Cambridge A2 Physics. And in this video, we will only focus on past paper questions. In the previous video, I have also explained one question about capacitance from past papers. If you haven't watched that video, you can go back to the channel and you can search for capacitance part 1. Here is our first question, and this question is simply asking us we need to state two uses of capacitors in electricals. There are many uses of capacitors, but we just need to mention two. If we mention two uses of capacitors in electrical circuits, we will get 2 marks. So we can say capacitor is used to store energy in a circuit. Capacitor is also used to block DC, and also we use capacitors in timing circuits. So these, if you mention, you will get full marks. So here is how you can write your answer. Here is part B, and for part B it is given to us that the combined capacitance between terminals A and B is equal to 4 microfarads, and there are two identical capacitors and their capacitance is C, and we need to find the value of their capacitance. Means we need to find the value of C as it is given in this question. We need to find the value of C, means the capacitance of capacitor C we need to find. Now how we can find out this one is a quite straightforward one. It is just based on principle of capacitors in parallel and in series. First of all, as you can see here, we have two capacitors connected here, and these two capacitors are connected in parallel, so their capacitance simply we can find that one will be equal to, their combined capacitance will be equal to 6 microfarads. Now we have three capacitors. Now let me redraw this circuit. You can see here we have three capacitors now, and we need to find the value of C. This capacitor has capacitance C, and this has capacitance C, and this capacitor has capacitance equal to 6 microfarad. And the total capacitance of this setup is also given, that is equal to 4 microfarads. We need to find the capacitance C. So how we can find out? So they are connected in series. So for series, we can find out 1 over C total has to be equal to 1 over C1, and this is just opposite to resistors in parallel. So this is the formula we need to use. Now as the C total means the total capacitance is given to us, that is equal to 1 over 4 microfarads, and 1 over C plus 1 over C and plus 1 over 6 microfarads. Now we need to just simplify this one. So one way to simplify this one is we can say 1 over 4. I will not write down microfarad, and we can subtract 1 over 6, and this one will be equal to, if we combine these two, we will get that will be equal to 2 over C. Now we can take the LCM. We can take LCM will be 24, and 6 minus 4 will be equal to 2 over C. And if we minus 4 from 6, we will get 2 by 24. So from here, as you can see, 2 is here, 2 is here, we can cancel, and simply we will get C is equal to 24 microfarads, and this is our answer. So here is our final answer for this part. For part B2, we need to find the magnitude of total positive charge transferred to the arrangements. It simply means that we need to find the total charge on positive plate of the capacitor. Positive plate of the capacitor. So when we talk about the charge on a capacitor, we always talk about positive charge on positive plate of the capacitor. So this is very important point, you need to be quite clear. So in this case we need to find the total charge. It simply means that for this arrangement we need to understand what is value of C total for this setup. C total for this setup, if you read question, it was given to us that is 4 microfarads, and we need to find the total potential difference between points A and B, and that is also given to us, that was equal to 12 volts. Now simply we need to calculate Q. So Q is simply equal to CV, and this is C total, and this is the potential difference between points A and B. So simply, as this is 4 microfarads, we just need to multiply this one with 12 volts, and if we multiply this, our final answer will be 48 microcoulombs. As you can see, the answer has to be in microcoulombs. Sometimes it's tricky one, you have to keep an eye on units as well. So final answer is 48 microcoulombs. This is how we can find. For this question, we need to find the magnitude of charge on one plate of a capacitor of capacitance C, and also the amount of charge on a capacitor of capacitance 3 microfarads. As you can see here, this is how the capacitors are connected in this arrangement. In order to find the amount of charge on one plate, so we need to reduce this circuit into 3 capacitors. And so as these two capacitors, they are connected in parallel, we can replace with one capacitor with capacitance 6 microfarads. So we can redraw this circuit. So if we redraw this circuit, it will look like this. It will look like this. So this is terminal A and this one is terminal B. This is capacitor C, and this capacitor has capacitance equal to 6 microfarad. We can also connect a battery here, so you can easily understand what is happening. Now, as you can see here, the total amount of charge we have already calculated in this setup. And these capacitors, now they are connected in series. It means each plate has the same amount of charge. So the amount of charge on this plate is equal to 48 microcoulombs, but this is positive charge. So this plate has net charge 48 microcoulomb. That's the reason the question was also asking you on one plate. So on this one plate, the charge is equal to 48 microcoulombs, and the charge on this plate will be negative 48 microcoulombs. And so we can write here. And on this plate will be positive charge, because these electrons, they will repel electron from this plate. So due to lack of electron, they will be net positive charge, and this plate will gain net negative charge. This plate will gain net positive charge, but all the plates, they have net 48 microcoulomb. So this plate will have net negative charge. Now, the first question is asking you capacitor of capacitance C, means the magnitude of charge on that one. So this is straightforward one. As we have already said, this is equal to 48 microcoulomb. Very easy to find. But the confusing part for many students is this one, how to find the magnitude of charge on 3 microfarads. So let me explain you first of all one point, maybe that will be very helpful for you. Let's say we have a big capacitor, its capacitance is 6 microfarad. We can replace this one big capacitor with 2 small capacitors like this. As you can see here, we can replace this one with 2 small capacitors like this. So they are equal. We can replace this one. Let me draw the arrow here. So you can replace this with this. So the capacitance of this one will be 3 microfarad. Capacitance of this one will be 3 microfarad. As you can see here, they are connected in parallel, and so they have the same voltage. So Q is equal to CV. So the voltage is the same, potential difference between plates is the same, and the C become half. How about the charge on each plate? As you see, this is half of this one. Charge you will also say will be half. So the charge on each plate will be equal to Q by 2. Simply we can say Q by 2, or we can say will be equal to 24 microcoulombs, and also the charge on each plate of the second capacitor also will be equal to 24 microcoulombs. In this case we are only talking about charge on one plate. But if you take the charge on two plates of capacitor, net charge will be equal to 0, because plates have equal amount of charge, but charge is opposite. So our final answer will be 48 microcoulombs on capacitor C and 24 microcoulombs on 3 microfarad capacitor. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about capacitors and capacitance from Cambridge A2 Physics. In this class, we will only focus on past paper questions, and today's question is from May June 2016, question number 7. This question is about experiment. With the help of this experiment, a student wanted to measure the charge on a capacitor for different values of potential difference across the capacitor. Experimental setup is given to us. As you can see here, voltmeter is connected across power supply, and this is variable power supply. Capacitor is also given to us. A switch is connected here, and a meter is used to measure the charge on capacitor. Student did this experiment and then he plotted data points. He took potential difference on x-axis and charge on y-axis. Data points are given to us. As you can see here, these red dots are data points, and 5 data points are given to us. What we need to find out, simply we need to state and explain that there is a systematic error in the readings of one of the meters. So how we can answer this one? Let me explain to you first of all what is systematic error. So systematic error is the key thing we need to understand. If we don't understand systematic error, then it is difficult to answer this question. Systematic error, first of all, we need to understand what exactly is systematic error. Systematic error simply means that our measurements will be greater than or smaller than actual value. For example, if we have value of G that is equal to 9.81 meters per second, and this is the actual value. If we got measurements like this, let's say we got measurement 9.2, then we got 9.1, again we got 9.3, and let's say we got 9.0. As you can see here, these values are very close to each other. We can say these values are precise, but they're not accurate, because these values are just lying on one side of actual value. They're smaller than actual value. This is also true if we got all the values greater than actual value. So it means there is systematic error in the readings. So this is one thing. So how we can answer this one now? How we can answer this question? So to answer this question, we need to understand Q is equal to CV. This one is telling us when the potential difference across plates of capacitor is equal to 0, the charge on capacitor has to be equal to 0. And vice versa is also true. When there is no charge on the plate of capacitor, means there is no net charge on each plate of the capacitor, there will be no potential difference across capacitor. So if there is systematic error in this case, so how we can see with the help of graph? So as it is given to us, Q is on y-axis and the potential difference on x-axis. If there is systematic error in Q over graph will look like this. And if there is systematic error in V, potential difference, our graph will look like this. Now, as these data points are given to us, we just need to draw the best fit line, and then we can see the systematic error. Is the systematic error is in potential difference, or systematic error is in charge? So first of all, let's try to draw the best fit line. So here is how we have drawn the best fit line. You can see here. So in this case, you can see when the Q is equal to 0, at this point Q is equal to 0, but the V is not equal to 0. It means that there is systematic error in potential difference, because the graph is, this line is not passing through origin. So this is our reasoning, and this is what we have found, the systematic error. Now let me explain to you how to write a proper answer for this question. So here is our final answer. This is how you can write down your final answer. So you can see here, the first thing we said, when the potential is 0, the charge store has to be 0, but it is not 0. It means there is systematic error. So if you write this one, you will get 1 mark. And the second, we have to explain now, because it has to be a straight line. It has to be a straight line if there is no systematic error, and it has to pass through origin, but in this case it is not passing through the origin. So that reason there is systematic error. If you write this point, you will get the second mark. So this is how we can answer. I hope it is quite clear to you. Let's move on to part B now. For part B, what we need to find, simply we need to determine the capacitance in microfarad of capacitor C. We need to determine the capacitance. So how we can determine the capacitance if the graph is given to us like this? So again, we need to understand that Q is equal to CV. And this is true when there is no systematic error. So we can also write down this one, that Y will be equal to mx. This is straight line equation. But now, as you can see here, there is a systematic error. I can simply say this is systematic error. Now, in this case, for example, the Q is on y-axis, and you can see the capacitance in this case will be equal to the gradient of the graph if we have Q on y-axis and we have potential difference on x-axis. And this is the case. As you can see, on y-axis we have Q, and on x-axis we have potential difference. So what we need to do, we simply need to find the gradient. So if we find the gradient of this line, the gradient will be equal to capacitance. So simply we need to find the gradient that will be equal to capacitance. So I have already calculated this one for you. So I will just show you my answer, and then we move to next part. There is nothing more to explain. So here, this is our final answer. So as I have calculated, I got this answer. This answer has 4 significant figures. We can reduce this one to 2 significant figures. If we reduce to 2 significant figures, we can write down this answer. So this is our final answer. Let's move on to next question now, the part C. Next one is part C. For part C, we need to determine the additional energy stored in the capacitor when the potential difference is increased from 6 volts to 9 volts. So now we need to understand how to calculate energy store, in a capacitor. So energy store in a capacitor, we simply calculate that E is equal to 1/2 CV square. As the potential difference is given, and C we have already calculated. Let's say this is energy E1, and here let's say is E2. So we will say V1 when the potential difference is 6 volts across capacitor, how much energy is stored in the capacitor. And when the potential difference across capacitor is equal to 9 volts, how much energy is stored in the capacitor. So we can find E1, we can find E2. So I will say this is V1, and here we can find 1 half CV2 square. This is. Now we need to find the increase in energy, means the additional energy if the potential difference increase from 6 to 9. So simply it means we need to find the difference between these two. We can simply say E2 minus E1. So as you can see here, 1 half CV2 square minus 1 half CV1 square. So what is common here in this case, if we look at this, 1 half C is common. Here this is common, so we can take this out. So 1 half C, so inside we left with V2 square minus V1 square. And then we just need to plug in values. We have value of capacitance from here, and value of V1 is 6 volts and value of V2 is 9 volts. And we just need to plug in values and we will find the additional energy stored in the capacitor if we increase potential difference from 6 volts to 9 volts. So this is the main process, and if we follow this one we will get our correct answer. But most of the time smart student, they often do like that, but that is not a correct way. They will say, oh, 1 half C and delta V squared, but delta V you will get wrong answer. So please don't be too smart. Don't do like this. You have to follow this. So let's go and do our calculations and finish this question. So here is our final answer. Let me make little more space so you can also see here what I have written here for you. I have explained to you how to do this question, and here just calculations. So this is our final answer. It has two significant figures, 2SF. That's all for this question. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about capacitors and capacitance from Cambridge A2 Physics. In this lesson, we will only focus on past paper questions, and this is fourth video on this topic. Part A is simply asking us to define capacitance. So this is kind of standard question. Most of the time you will see if there is any question about capacitor in exam paper. So how we can define capacitance? So this is very simple concept. Simply we need to understand that Q is equal to CV. Simply Q is equal to CV. So from here we can define the capacitance. We can say that C is equal to Q over V. So we can define that charge per unit potential difference, that is the capacitance. So this is how we can define capacitance. Charge per unit potential difference across plates of capacitor. For this question, an isolated metal sphere is given to us and its diameter is also given, that is equal to 25 centimeters. We need to show that its capacitance is equal to 1.4 times 10 to minus 11 farads. First of all, let's try to sketch this one so we can see what is happening. Metal sphere. So this one is sphere. And you can see it is given to you very clear is a metal. It means that all the charge will reside on the surface only. So it simply means that the charge will stay on the surface. So this is the charge on the surface. So we can just draw like this. So you can see what is happening. Let's say its radius is equal to R. Radius is equal to R. But in this question, diameter is given to us, so we can find the radius. So the radius will be equal to diameter divided by 2. So our radius will be equal to 12.5 centimeters. So we can also convert into meters. So we just need to multiply with 10 to minus 2. So this is radius in meters. We need to find the capacitance. We need to find the capacitance. So as we already understand that capacitance Q is equal to CV. Already discussed that Q is equal to CV. So we need to find the C. So simply we can say C is equal to Q over V. Now we need potential at this point, means potential at the surface, KQ over R. Otherwise, we can also write down that Q over 4 pi epsilon naught times R, because the K is equal to 1 over 4 pi epsilon naught. So this is value of K. K is equal to this. Now we just need to simplify this one. As you can see here, we have Q here and also we have Q in the denominator. So this is Q over 4 pi epsilon naught times R. So Q we can cancel with Q. As you can see here, Q is here, so we can cancel. So the C will be equal to 4 pi epsilon naught times R. So we can also write down this again. So C is equal to 4 pi epsilon naught times R. From here, we can see that capacitance only depends on radius of the sphere, means the size of the object, and it also depends on medium. So this one is the radius of the sphere, and also it is depending on the medium. Epsilon naught actually is permittivity of free space. So it means value of capacitance is depending on these two. But this is not our final answer. For final answer, we need to find the value of capacitance. We simply need to plug in values, that all. So let's clean first and then find the value of capacitance. So we have found that C is equal to 4 pi epsilon naught times R. So 4 pi epsilon. Epsilon, the value of epsilon is permittivity of free space. This is 8.85 times 10 to minus 12. And the radius is 12.5 times 10 to minus 2. We just need to multiply. Our final answer will be 1.4 times 10 to minus 11 farads. So this is how we can answer this question. We need to be just careful with units, otherwise this is very straightforward one and we can find answer quite easily. For part B, simply we need to find the combined capacitance of the capacitors. Simply speaking, we just need to find the total capacitance of this network. In order to find the total capacitance, first of all, we need to identify capacitors connected in series and capacitors connected in parallel. As you can see here, these two capacitors are connected in parallel. So simply it means the total capacitance for these two capacitors will be equal to 2 plus 4 is quite straightforward one. So our final answer for these two capacitors will be equal to 6.0 microfarads. Now if we reduce this circuit, now we can see here we have two capacitors. They are connected in series. We have one capacitor, its capacitance is 6 microfarad. So this capacitor has 6 microfarad capacitance and the other one has 3.0 microfarad. And both of them, they are connected in series. We need to find the total capacitance. So it's quite straightforward one. We can multiply their capacitance and we can just then divide by sum of their capacitance. Means 3 plus 6. Our final answer will be 2.0 microfarads. This is what we need to find. Quite straightforward one. Our final answer is 2.0 microfarads. For this question, we need to find the potential difference across the capacitor of capacitance 3 microfarad. Simply speaking, we need to find the potential across this capacitor. But in the previous part, we have already found the total capacitance of this setup, means this network. And the total capacitance was equal to 2.0 microfarads we have found. And total voltage, means the EMF of the battery, is also given to us. That is equal to 9.0 volts is also given. So we can find the total charge on all these capacitors simply by CT, means the total capacitance. If we multiply with EMF of the battery, we can simply find the total charge. In this case, total capacitance is 2.0 and EMF of the battery is 9. So simply if we multiply, our answer will be 18 microcoulombs. So what exactly it means? It means this is the total charge on all these capacitors. So let's redraw this circuit again now. So we can redraw this circuit like this, means we can replace these two capacitors with one single capacitor, and that one single capacitor has capacitance that is equal to 6 microfarads, means we can replace these two with 1. So this has 6 microfarad and this capacitor has capacitance 3.0 microfarads. And as these two capacitors, they are connected in series, it means they have the same amount of charge. They have the same amount of charge. So what exactly it means same amount of charge? Means this capacitor has charge that is equal to 18 microcoulombs, and this capacitor also have charge on positive plate that is equal to 18 microcoulombs as well. When we talk about charge on a capacitor, we just talk about charge on positive plate, means the net charge on positive plate. So from here we have found that the charge on 3 microfarad capacitor is equal to 18 microcoulombs. And we have its capacitance. We need to find the potential. Simply we can say the potential difference V will be equal to charge on positive plate of 3 microfarad capacitor divided by its capacitance. Charge is equal to 18 microcoulombs, means 18 times 10 to minus 6, and its capacitance is 3 times 10 to minus 6. So the potential difference is equal to 6.0 volts. Next question is asking us to find the positive charge stored on the capacitor of capacitance 2 microfarad. As you can see here, 2 microfarad is connected here. In order to find the charge on this one, means the positive charge on this one, simply we need to understand that Q is equal to CV. Simply we understand Q is equal to CV. We need to find Q, so we need the value of its capacitance that is already given to us, that is 2.0 microfarad, means 10 to minus 6 farad, that is given to us. We just need the potential difference across this capacitor. If we remember, in the previous part we already have calculated the potential difference across this capacitor, that was equal to 6 volts. If the potential difference across 3 microfarad capacitor is 6 volts, then the potential difference across this one will be equal to 3 volts because EMF of the battery is 9 volts. So the potential difference across 2 microfarad capacitor is 3 volts, and just we need to multiply this and we will get our final answer. So in this case the final answer will be 6.0 microcoulombs. This is our final answer. Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about capacitors and capacitance from Cambridge A2 Physics. In this lesson, we will only focus on past paper question, and today's question is from March 2016, question number 7. Part A is simply asking us to define capacitance, and this question is kind of typical question. You will see this question again and again in many past papers. So now how we can answer this one? So this is quite straightforward one. Simply we need to understand Q is equal to CV, and C is the capacitance, so we can say C is equal to Q over V. Simply we can say charge per unit potential difference. So this is how we can answer. For part B, simply we need to find the total capacitance of capacitors connected in series. As you can see here in this circuit, these capacitors are connected in series, and these capacitors are not identical capacitors, mean their capacitance is different. Simply we need to derive this formula. So how we can derive this formula? We just need to understand one key concept. If we are clear about that concept, then we can derive this formula. And that concept is same charge when capacitors are connected in series. Same charge when capacitors are connected in series. So how they get the same charge? So let me little explain to you. Can see here, this is positive terminal of the battery and this is negative. So the plate with positive terminal of the battery will gain net positive charge, and the plate on the negative side of the battery, means next to negative terminal, will gain net negative charge, and the plate next to negative will get net positive charge, means will be positively charged, because electrons will be repelled from this plate and electron will come to next plate, and these electrons then repel electron from next plate, and this next plate become negative. So this is how these plates are charged, means the capacitor is charged. So in this case there is the same amount of charge on each plate, but we need to be quite clear about this one, as Q is equal to CV, as Q is the same on each plate but C is different. If the C is greater, potential difference will be small, and vice versa. So if big capacitor, potential difference will be lower. If it's a small capacitor, potential difference across that capacitor will be higher. So based on this one, we can derive formula. So this is, I have already derived this one for you. So you can see this is quite neat and clean. So I will explain you the main concept now. So that's all for this part. As you can see here, V is equal to V1 plus V2 plus V3. It simply means that the total EMF of this battery is equal to V1 potential difference across first capacitor plus potential difference across second one plus potential difference across third capacitor. As we understand, Q is equal to CV, so simply V is equal to Q over C as we have written here, and Q is the same, so simply we can cancel Q, and our final answer is this one. This is what question was asking us to show. So this is our final answer. In the last 4 videos, we have discussed a lot about capacitors in a circuit, and this part C is about capacitors in a circuit. So the most important thing what we need to understand is that it is given to us the switch has two positions. As you can see here, A and B switch is here. We can move this switch to A or we can move this to B. Part C1 is asking us when switch is moved to A, we need to find the combined capacitance of two capacitors. These two capacitors only we have in this circuit, and here is a resistor and here is power supply. We simply need to find the total capacitance. So when we move this one, switch means we move from this point to here. So you can see here these two capacitors, they are connected in series now. So we need to find simply total capacitance. I will not talk a lot about this one. I will simply show you the answer and little explain because we have discussed a lot about this. As you can see here, as capacitors are connected in series, the formula simply we use 1 over C has to be equal to 1 over C1 plus 1 over C2, and this is what I did here, and this is our final answer. So this is 150 microfarads. This is our final answer. 200, 600, simply we solve. This is our final answer. So let's move on to next part now. This is C2. You can see here we need to find the charge on 600 microfarad capacitor now. As we understand, these two capacitors, they are connected in series, so it means they have the same charge. As they're connected in series, it means they have the same charge. So we can simply say this is the key concept. We have to be quite clear about this one, and also you need to understand, as we are talking about this C1, and C1 has again two parts, part 1, part 2. It means still we are considering when switch is moved to A. So this is important point. You have to be clear about this. You need to understand how to read questions. Same charge. So how we can find the total charge on capacitors? Simply we can find the total charge, that will be equal to QC total times EMF of the battery. In this case, the total capacitance we have found. So this is the total capacitance. This is 150 microfarads. We can write down 10 to minus 6 because it is in micros, and we need to multiply by 12 volts, and that will be our final answer. So in this case, if we multiply, our final answer will be 1.8 times 10 to minus 3 coulombs. So this is our final answer. And 1.8 times 10 to minus 3 coulomb charge on 200 microfarads, and also it is the same amount of charge, 1.8 millicoulombs, I can simply say, is on 600 microfarads capacitor. For this part, simply we need to find the potential difference across the 600 microfarad capacitor. We have already found the charge on 600 microfarad capacitors. If you remember from part 2, we have found that the charge on 600 microfarad capacitor is equal to 1.8 times 10 to minus 3 coulombs, and its capacitance is also given to us. C is 600 microfarads. It means 600 times 10 to minus 6 farad. So this is what we need to find. We need to find the V. So we can say V is equal to Q over C, because we understand Q is equal to C. V. We just need to plug in values, and that is our final answer. So this is 1.8 times 10 to minus 3 coulombs divided by 600 times 10 to minus 6 farads. If we solve this one, our final answer is 3.0 volts. Now switch is moved from A to B. As you can see here, switch is moved from A to B. Now this is our circuit and battery is disconnected. In this case, capacitor will discharge. So simply we can write down capacitor will discharge because there is no battery in the circuit. So what we need to find out, we need to find the potential difference. We need to find the potential difference across 600 microfarad capacitor when it has discharged 50% of its initial energy. So simply we can say its initial energy is equal to E. For example, we can simply say initial energy is equal to E naught. And E naught we can also calculate because we have value of potential difference across 600 microfarad. So we can say energy is equal to 1 half CV square. We can also replace V with its value, and that is equal to 3. So this is the initial energy. Now the final energy is half of initial. We can also say EF is equal to E naught by 2. We can also say that E naught is equal to 2 times of EF. This is our main result, and rest is just we need to plug in numbers. So as you can see here, so this one is the value of E naught. So this is over E naught, and this one is E final, and the C is common on both sides. We can cancel, and if we solve for V, so this will be our final answer. So the value of potential difference is 2.1.